Let's begin. So this is the what's the course called? Safety 1051. 1051. Tools and workplace techniques. My name is that's my name. I prefer to be called by my last name. It's just that goes with my personality. Some people will let you call them by the first name. That's okay with them. I prefer to be called by my last name. Now, as far as the logistics, when it comes to writing emails, just a couple small rules, just to get you into good habits of writing professional emails. Try not to call me by my first name in the email. Just use my last name. That's appropriate here. Also, if I see an email beginning with the word "hey," this is as far as I read. Okay. Now, as far as proper emails, let's get you into good habits. I use the format that is called Scrap. See? Scrap. And it goes like this. Situation, complication, resolution, politeness. Okay, application. Situation, complication, resolution, application, and politeness. You can Google that format. It's a very popular format. If you get into a habit of writing all your emails in this kind of format, some of the doors might actually open to you in corporate world, or some doors will not be closed to you, because sometimes when it comes to employability, quite often you are not going to even get an interview, and you will never know why. Okay, so that's that's just a quick thing here for us. Just erase this here. Okay. We got a lot to cover. So the lectures, we're having 1 hour today, and we're going to have 1 hour tomorrow with all class present. And we do have a lot to cover, actually. Labs are going to be bi-weekly. So everybody pretty much got the lab schedule. The lab schedule got a little bit changed. Nothing changes with your times. So as far as you're concerned, you're coming to class at the times as it was. It's just the instructors' names were a little bit messed up. So now the revision 2, it's posted in the class portal. Let me just see if I can call it up here. All right, so this is our class portal. It's going for you. It's going to look like, for me, it looks like this. We're going to have different courses. So this is our course right here. And if you go to the announcements, here's the revision 2 posted. It's the same. All right, so now let's just take a look at the lab schedule first. Have that. Lab time schedule. Okay, just gonna call this up. Get this, yeah. We're looking at that. All right, so I guess I'm going to have to change the screen resolution, but we see enough here. So section, just find your section, wherever your section is, section 1 or section 2. I have sent emails to everybody. The email said, if you receive this email, you're in section so and so. So everybody should know what the sections, what section they belong to. If you're just admitted to the course and you didn't receive that email, by all means, send me an email and I will tell you what section you're in. Sometimes in your little stamp that is in your communications from the college, you will see what sections you are. Sometimes they are listed as numbers, those sections, and sometimes the sections are listed as letters, A, B, C, D, E, A, B, C, D, E, F. Right? F finger. Okay. So, but if you don't know, just by all means ask. Okay. Now, as far as the sections, where's my laptop here? There we go. So, so the sections as laptops. Your section. So all you have to know when it comes to lab schedule, just pick your section. Let's say you belong to section number 4, right here. Okay? So that's all you're concerned with. That's all you need to look. You don't need to look at the other sections. So section 4, and you just go down the table. Your lab 1 is Wednesday, September 30th. Okay. What is the next lab? Oh, here is another lab that says no lab. The reason why all these 2 weeks are going to have no labs is because that this is going to be our Thanksgiving weekend week. All right. So, and one of the sections is being affected by that. So, if we continue with the labs with all the other sections, but not that one, then we're going to have things thrown off balance. However, I'm going to come up with something that we're going to meet online, and maybe we can talk about things that maybe you have troubles with, or maybe I'm going to give you some more content. So that is going to be decided. So just allocate those times for labs, anyways. But it could be some kind of online meetings or such. Okay. So that's as far as the lab schedule. Now let's quickly look at the course plan. Course plan that is, okay, I'm just going to go to our class portal. The course plan, you can see under the content section right here. If you click on that, you're going to see course outline. And if you scroll down a little bit, you're going to see the course plan. If you notice, this course plan is posted from last year, so this is not the proper course plan. Dates are out of order, everything is out of order here. The content is more or less the same, but it's just going to be organized a little bit differently, and I just happen to have the proper schedule that we have here. So that's our course plan, and that is going to be inserted where the old one was. Okay? So tools and workplace techniques is the name of the course. Electrical techniques, yeah. ELT11 applied art, science, and technology. Okay, so I'm just going to have to change that. 13 weeks, fall 2020. This is my name for the theory. Now, right away, you're going to see the labs. We are going to have 5 labs. If I can just zoom this thing in here so we can see things better. All right. So 5 labs. Lab number 1, which is happening this week, and that lab is going to be on multimeters. Now, we are not going to perform that lab face-to-face. Every year, there is a problem with the kits, with the toolkits, with the hard hats and boots and whatnot. So anytime I was planning to have proper lab as the first lab, it never worked. And people had to make things up, but this year there is no makeup labs, so we're just going to have to deal with that in such way. So I designed the first lab is going to be the theory lesson for today, and the theory lesson from tomorrow, and we're just going to have an online questionnaire for you to do, and that is going to be a mark for the lab number 1. Now, there are Sometimes people are saying, online, can people cheat? Can people get other people to do it? Well, academic integrity is not tolerated in our school. However, I'm going to I'll tell you something else. This is going to be the lab on multimeters, and I have reordered the labs from last year because in the suggestion box, the virtual suggestion box at the end of the term, one of the students, has suggested that the multimeters should be taken care of first, not towards the end of the course, because you are going to use those multimeters in all your other classes. So it would be a good idea if we could take care of those multimeters first. And I looked at that suggestion and I said, hey, you know what? That's a great idea. All right. So I have switched the multimeters theory and the lab that has to do with multimeters for the very beginning. So can you cheat on that? Yes, if you really, really, really try, you can find your way as far as cheating all your courses. And I would say most of the times you will be caught, and it's not pretty. Right? However, I'm going to tell you that please do not cheat on this one or any other lab, simply because if you don't know how to use the multimeter, you're going to be in trouble for the rest of your other classes. So just learn the damn thing here. Okay, we're trying to give it to you as much as possible and as best content as possible, so you can use it in school, and so you can use this thing later on in your when you leave this school. What happens if you cheat? Well, yeah, you're gonna get some good mark, but if you don't know how to perform something, if you don't know how to do your job, do you think you'll be able to get the job? Even if you have a good mark, even if you pass, or if you get the job, do you think you will be able to keep that? Well, so here's that. Here's my Van by the River motivational speech. All right, there you go. All right, should we get our multimeter for this presentation? No, you don't. You don't have to. I'm just gonna try to see. What room do we get for these in-class labs? Yeah, okay. The room is labs. Labs. Room P and 23. It's supposed to be 10. Room 10 T23. It's probably the biggest lab room. It looks like a construction site. If you walk, let's say, how do you get to that room? The best way, let's say this is Oxford Street, and this is the T building. This is where the bus stop is. The buses, and this is a little road here. And here's a big T building, and here's an entrance to that T building. Once you enter to that T building here, you're going to see. Let me just lower the lights here so you can see things better. Lights. Slow, but now you can see things better. All right, so let's say this is the T room here, T building, the big building here. You enter that door, you go this way. This is west towards Windsor. This is east towards Toronto. Okay. Now, enter that. This is the entrance to the T building. Over here, you're going to see immediately on this side, you're going to see the elevator. And here you're going to see some sort of a big kind of a sculpture with some guy that has a hammer or some kind of a thing. So the big sculpture there. And if you're standing there, the room is right there. It's a huge room. Okay. Now let's that's T1023. Right, let me just erase this map here. All right. And a dry rag. bit hard to erase this glass bar here. I might as well get this thing here off too. Just I do all this here for you, so I have a clear view of my beautiful face. All right. Okay, let's get some lights on. All right. I got my workout for today. All right. So the labs, lab number one. Okay, here, let's get some laptop here. Lab number one is the multimeters. Lab number two is going to be a cable preparation. And during that lab, we're going to strip something that is called NMD90 cable. Sometimes it's called Romex. It is the regular cable that we use for household installations, electrical installations, okay? And we're going to put that onto a duplex receptacle, and you're going to be evaluated on what you do. And you're going to be presented, you're going to have a in-class demo on how to do this. In lab 3, pigtails, you will know what that is. It's just basically using the wire nuts from the red connectors to join wires, and there's a certain technique that I want you to know how to do. Then we're going to do box offset. This has to do with the pipe bending, conduit bending. You're going to perform your first bending of the pipe. It's going to be it's the simplest pipe bend, and later on, next term when you get probably Mr. Crouch for the course, you're going to do some more complicated bends. And then lab number 5, we're going to connect something that's called a three-way switch. All right, there it is. Okay. All right, now let's see the course content and evaluation. All right, so notice that there is no final exam this year. Yeah. However, you're still going to have to be evaluated on everything that you do. So the questions that used to be on the final exam, they're going to be asked during the tests 1 and 2, and maybe the quizzes. So let's see how that looks like. Labs. All the labs are worth 50% of the whole course. Okay. That's a big weight. All right, 5 labs. Each lab is worth 10% of the course. So you got to attend those labs, and you got to do them properly. 2 quizzes. Each quiz is going to be worth 5% of the whole course, and we're going to have an assignment that you're going to produce some drawings that have to do with connecting three-way switch, probably, most of the time that is. And then we're going to have 2 tests, each worth 15%. And if you get your calculator, add all these numbers, you are going to come up with 100% of the whole course. Okay. Just dates to remember, midterm grading is going to be presented to you by October 30th, and the midterm is just satisfactory or unsatisfactory progress. So it's just like taking the temperature of your progress. Okay? And the final grades will be given to you by December 22nd. Okay. Now, let's zoom out here. This is pretty much finalized. Lectures, week 1. Course introduction, this is what happens here now. So I hope we're going to get some multimeters started. And then household wiring, that's going to be week 2. Hand tools, boxes and devices. So of course, electrical boxes and devices. And conduits and raceways. Then we're going to have a test. I'm still trying to make sure that these tests dates, so that those might change slightly, or maybe not. The test dates or the weeks are going to be Just want to make sure that they are not conflicting with other courses here, other tests, so your heads don't explode with having to get ready for too much. Okay? Then conduits and boxes and wires, that's what we're going to be looking at that. So conduits and raceways, that will be continuing from with the conduits and boxes and wires. There's a reason for that. Ladders and scaffold safety, power tool safety, working with wiring diagrams, that's when you're going to get your assignment done. Then we're going to touch on the arc flash. And week 12, that's a mistake. There's something else here. I don't know what that is. See, it's a good thing I caught it. All right, that's going to be corrected before it's emailed to you. Okay. Now let's take a quick look at the chat lines here. Building clean. I see. Should we get more to know? Are these tests open book? Well, sort of. I'm still trying to decide whether if I can get you into a room, but if I can't get into a room due to COVID regulations, then we're going to have online quizzes or online tests. And if you think that my online quiz, just because it's online, do you think that's going to be easy? I have adjusted the difficulty of the online quizzes, so you actually have to demonstrate your knowledge of the content. You just have to learn things. And how I'm going to evaluate that, I'm going to find a way to evaluate that actually the evaluation reflects your knowledge of this content. All right, asking because there are other classes with open book quizzes and okay. So probably, most likely, there are going to be online tests, but we're going to have to set up so it's just if you were coming to your class, and it's going to be at the same time for everybody, and so on and so forth. Okay, did we take care of everything we needed to? As far as the logistics so far, yes. Now let's take a look at some of the content here. Right, you know what? We're gonna skip the safety thing because I can just post that. I can post the safety rules and regulations. You can read through those post-it notes yourself. It's pretty straightforward. And I'm going to have a little questionnaire for you to fill out online. So after this week, I'm going to design a little quiz that has to do with safety. You're going to have to answer that, and it's going to be part of your mark. So let's just skip through that safety thing. Let's just go right on to our multimeters. Where's our multimeters here? Yeah, there we go. So we're going to have two lectures. We're going to have two lectures on multimeters. Today there's going to be more like theoretical part, and tomorrow when we meet, I'm going to bring some real stuff like this one, for example. Here, just where is it? Here it is. Okay, like this is an analog multimeter. Can we see it closer? Yes, we can. I want you to know this is just a little $20 thing that I picked up at Home Hardware. By no means this is something that I would use in the industry. However, this is a great tool to show you how to use an analog multimeter as opposed to the digital stuff that, for example, this one here, that one right here. Most of the multimeters you're going to use are going to be digital. However, sometimes you want to use an analog meter because of the type of the voltage or current that you're going to measure, and the analog meter is not going to work. Sorry, digital meter is not going to, it's just not going to cut the mustard. All right, so, okay, let's just keep going. Multimeters and other circuit testing devices. We still attend Mr. Crouch's safety class, even if we are. Yes, okay, yeah. So the labs, you still come to the labs, because during this time, we're going to use that time to show you the ropes around it. Like a lot of things have changed since last year because of the COVID situation. So yes, by all means, come to class, get your orientation as far as the labs, rules and safety by your instructors, and what tools do you need to bring, and so on. Tools. Well, let's just quickly go to the tools here. What we need for tools is you need side cutters for our class, but bring a whole tool belt. But if you don't, at least you need to use side cutters. Okay. You need basic screwdrivers. I just picked this up at some not dollar store, hardware store. These are basic screwdrivers. We have a red Robertson, we have a green Robertson. Robertson is the square type of a screwdriver, and we have some Phillipses. So just the regular Phillips, and then the one a little smaller than the regular Phillips. So the regular Phillips is going to be number 2, and the little bit not regular Phillips that is we're going to use is going to be number 1, because some of the screws just have tighter footprint. And a good slotted screwdriver. I don't want to use the terminology as flathead, because flathead goes to the type of a screw head. So we're just going to use the terminology. Quite often you're going to see in construction site, somebody saying, just hand me a flathead screwdriver. That's okay if somebody says that. Just don't hang them because of that. All right? But the proper terminology is a slotted screwdriver. Right? And then you're going to need, aside from this, I'm just going to stop the PowerPoint for a second. Aside from that, you will need a stripper, something like this. Right? That's our stripper. That's for stripping the cables off the insulation. It has different size of grooves for stripping wire, and you're going to be shown how to use that. But for sure, you will need this for your first lab, which is going to be probably after Thanksgiving. So you have a lot of time to get your tools organized. But you will be also presented with the tool list. So hopefully somebody's going to have your toolkits. So bring them to your lab. So maybe your instructor, Mr. Cunningham or Mr. Crouch, are going to be able to show you some of those. Okay, that's as far as that. Let's just keep going with the multimeters. All right. How much time do we have? We are not going to go to the whole lecture today because we have half an hour left. But let's see what we're going to accomplish. All right. All right. Multimeters and other circuit testing devices. Let's just keep going. What is a multimeter? Okay. By the way, you should be able to bring me up on my view on full screen, and that's with my classes. I have organized my teaching station in a way that all you have to do is bring me my view of pretty face on the full screen. Okay, that's all you have to do. I'm not going to use any screen sharing or using whiteboards. I have all the equipment here that we can just do the classes as smooth as we possibly can. All right, so multimeter is a device. Multimeter is a device used to measure voltage, resistance, and current in electronics and electrical equipment. Well, the difference between a multimeter and a hammer is that multimeter can do more than one thing. That's why it's called multimeter. Using certain multimeter models, you can test to be sure that components such as diodes, capacitors, and transistors function, and other devices function properly. Different meters for different objectives. Streamer, you have this. Am I a streamer? Oh, you know what? I could be, but I don't have time. I used to be in entertainment. Yeah. Did you hear of me? No? That's too bad. Okay, anyway, okay, let's just keep going with this. All right, using certain multimeters. Okay, so you can test different components, and I'm going to show you. So tomorrow I'm going to bring some devices, and I'm going to demonstrate how they work. Now this is recorded. This whole thing is a recorded session. So just keep in mind, that this is recorded session. So whatever you say, sometimes you might want to be on record, or sometimes not. All right. So you can also troubleshoot your circuit to see where the current is failing and pinpoint the problem spots. Okay, that's a mouthful here. Very complicated stuff. It is also used to test continuity between 2 points to verify if there are any breaks in a circuit or a line. Okay. And advanced multimeters are capable of graphing and printing waveforms and doing all kinds of wonderful things that you haven't even dreamt of, but you'll be able to see some of that in this course. 2 basic styles of multimeters: analog, where the value of the measured quantity is displayed in a mechanical pointer against an analog scale. So let's see here. Here I have one of those. It is the reactor. Let's look at the reactor meter. Okay. So over here, that's what I mean. Bring it closer here. Focus. There we go. So here's a needle that you can see moving. Okay. And the needle is going to show you the value that you're measuring depending on what scale you're going to use. And I'm going to show you all that tomorrow. Right? There. So the value is being used by mechanical pointer, right? That's what it looks like, and I just showed you that. And then there is a digital. The value of the measured quantity is displayed on a digital readout, just like that. You can see 3999. Okay, so that's 3,999 something volts AC. That's a huge voltage. Don't touch that. Okay. Now, displays other than LCD, what I have done here is, because I just used the word LCD, what other displays do we have? Now, that I'm not going to test you on. However, when you download the PDF version of that, you will be able to click on these links in order to see what other type of displays see here. So just all these are links. Right, and it actually says, "Oh wow, there's an arrow pointing," and it says "click to see examples." Right, so I just throw that in. Oops, that's not this computer. It's this one here. 2 basic style of digital multimeters. Now, switched and auto range. Okay. This is an example of a switched multimeter. Can I zoom this thing in here or not? Oh, I can't. All right, I can't. However, here is the dial and the pointer of the dial. And over here on the switched, you have to set the type of the measured quantity that you're going to measure. Like, let's say, for example, voltage. And over there, you also are going to be able, where's my mouse? You're going to be able to set the range. So let's say you're going to measure voltage from a power supply that is going to be something around 30 volts. So you're going to set the range of up to 30 volts. And if you can't find up to 30 volts range of the voltmeter settings, then you're going to go to the next up. Okay. So you have the control. It's just like driving automatic or standard. Now here's the automatic. Oops, wrong one. Okay. Here's the auto range. Over here in the auto range, you just select voltage, AC voltage, and that's it. And the meter is going to calculate the range automatically. Both kinds work just fine, so just a matter of preference. Some people like this type, some people like the other type. There could be reasons. So manual switching between functions and ranges. Function would be measuring voltage or measuring current or measuring resistance and so on to get the most accurate reading Now, for the auto range manual function selection, so you're just sending out voltage, current, resistance, or whatever, and you don't need to worry about the range of things. The meter is going to be so smart that it's going to give you the most accurate type of reading. And I'm going to show you tomorrow what exactly I mean by selecting proper ranges. All right, so I'll just look at that. I can make this thing red. All right, so most accurate reading, and I just made a note for myself, says elaborate on that, okay? So how can we elaborate on this most accurate reading? Okay, let's say you have an analog meter and you have a scale on the analog meter. Say here's a scale. You're measuring voltage. Here's 0 volts, and let's say here is 100 volts. If you are going to measure voltage that is like 3 volts, it's going to show up somewhere here. The needle is going to bend just a tiny little bit over here, somewhere there. Now you're going to see this is 3.5 volts or is it 3.6 volts. It's not going to cut it. It's just going to say it's very low voltage. But if you had another scale, you switch the range, another range. Let's say this one is from 0 volts up to 10 volts. Okay? Or let's say up to 5 volts, if there's one like that. Then the needle is going to bend somewhere here. This way, you will be able to tell whether it's 3.5 volts or 3.6 volts or something like that, or 3.5 volts. Over here, you won't be able to. So that's what I mean by most accurate reading. You want to have the range. So this is the range of 100 volts, and somewhere you're going to have a dial that you're going to select the voltage. Say volts DC. This is going to be 100 volts, up to 100 volts. And over here, maybe you're going to have another one that says up to 5 volts. So I would just move that dial right here. If I move the dial here, I'm going to use that scale right now, the top one here. So that's as far as selecting ranges. This is something to do with using analog meters, but the digital meters work just the same. You want to have your voltage or your current or whatever you're measuring, you want to have this thing as close to the end of the range that you selected to get the most accurate reading. Okay. Now, categories of meters. You can see here that we have selected category 2, category 3, and category 4. I'm not sure if you can see this properly on your screen, and on the recorded session when you watch it, you're not going to see that for sure, because I just looked at the bongo. I'm actually considering switching to Zoom sessions because the quality is much better during the recording. So I'm just going to read that for you, but you will be able to view this thing when after tomorrow's lesson. I'm going to post those notes, and you can download them from the course content, and you'll be able to see that yourself. Okay. Now, so category 3 meters or category 3 devices or loads. Category 3 loads would be a single phase receptacle connected loads. So single phase receptacle, where do we see here? That's just a receptacle that's in the wall. That would be a category 3 type of a load. Examples of that would be category 2. That's category 2. Category 1 not there. Yes, we're not listing category 1. But some people think that there is. Maybe there is category 1. There isn't. It's not worth to mention because category 1 is all the devices that are not powered. So we're not going to be concerned with that. We're going to talk about things that are powered. So the example of the category 2 would be appliances, portable tools like a toaster or vacuum cleaner or whatever. Outlets at no more than 10 meters or 30 feet from the Cat 3 source, or outlets that are no more than 20 meters or 60 feet from the category 4 source. So let's jump the categories here. Let's look at the category 3. That would be a 3-phase distribution, including single-phase commercial lighting. So there would be higher power here, okay? Examples of that would be equipment in fixed installations, such as switchgear and polyphase motors. So you're talking industrial applications here. Bus and feeder and industrial plants. So you're talking industrial environment. Again, distribution and panel devices. So where do we have in household category 3? Your panel, your electrical panel is considered to be a category 3 load. In the commercial environment, category 3, again, that's a panel, and the transformer also is category 3. Now, category 4, if you notice, category 4 is pretty much a general rule. Most of the time, it's going to be outside. 3-phase, a utility connection, any outdoor conductors. So let's say here, yeah, it's about blurry. Yeah, I know. Now, when you have this thing, I'm going to post it online as in the recording. This recording is going to be posted online, so you can view it later on if you want. You can study for your tests and so on. But I'm explaining this thing to you right now as well, right? So category, and you're going to have posted notes as well, so you're going to see everything clearly. Where's my mouse? Here it is. Category 4 is pretty much outside. So the outside meter, see here, in your house, the outside meter, that's considered to be category 4. And the line that goes from the outside transformer to your house, that's also considered category 4. So that's about the categories. Now, the categories of the loads should be matched with the categories of the meters. So the meters have categories. Okay? Let's say the one that you have at the back, it says, I just took a picture last year and magnified this whole thing. There's a little bit of a stamp here. It says 600 volts category 3 and 1000 volts category 2. So with this meter that you have, you're able to measure, check the stamp, something could have changed. You can measure up to 600 volts of category 3 source. So if you think that there is category 3 source here, 600 volts, you can measure that up to 600 volts in the electrical panel, for example. And you can measure up to 1,000 volts if you're dealing with source of a category 2. So category 2 would be an outlet. If you think there's 1,000 volts in this outlet, you can measure with the that with this multimeter. What happens if you mismatch the categories? Of course, you can use a meter that is designed for a heavier load. You can use it on a lighter load. Yes, you can. But you can't do it the other way. You can't use a meter that is designed for lower type of a load, and you cannot start doing measurements on a higher type of load, because you're running into a danger of an arc flash. That thing can blow up in your hands, so you can get some burns. And when it happens to arc flash, we're going to have a whole unit on the arc flash. You can actually die from arc flash. Okay? It's a huge explosion. But we're going to talk about that later. So now, just because I'm showing you this thing, don't go haywire with things. Start measuring. Don't do that yet. All right. The expression of knowing just enough to be dangerous. Just go along with the course a little bit before you can start mucking up with the household wiring and all that stuff. Just don't do that. Okay? All right, let's go back to our PowerPoint. How much time do I have? Oh, it's 2:47. I feel like the first 2 weeks in co-op course in high school was watching people take well, if they're still alive, then you didn't see a proper arc flash. Okay? And the thing is that if you have seen a huge arc flash, you probably wouldn't be here, because you would see that thing maybe for a split second. I'm getting tangled with my wires here. All right, let's keep going here. Type of meters. Meters can be very simple. And I have a picture for you here of simple meters. Okay. This is a digital on the left side here. We can see a digital meter. And that looks like it's a very, very, if I can say that, very auto range. What can you measure here? You can probably measure resistance, continuity, and maybe there's some functions here to select voltage and whatnot. But this is a very simple meter. This is another simple meter example. Another simple meter. This is a clamp-on meter. I'm going to show you how to use one of those. Though that clamp thing looks kind of intimidating, but you know what? It's not. Seriously, after tomorrow, you will be so enlightened that you're going to have to get a bigger hat, because it's not going to fit. Your head is not going to fit there. Anyways, or the meters can be complex, such as this. For example, you could use a multimeter instead of intended for cat 4 to measure cat 2. Yes, you can. Yeah, but not the other way. Just want to confirm that. Yes. Because if something is designed to be heavily used, you can measure something that's that's a toy, right? But if you have something that you can only handle lower voltage, and you're going to start measuring higher voltage, you can get yourself into trouble. All right. Now, so type of meters, yeah, they can be simple or they can be complex. Now, the complex meters usually require some manufacturers training. So don't worry that there's no way. I'm 30 years in this business here. Do I know how to use all the meters? Of course not. Do I use the basic meters and whatever I had to use for the purpose of what I was doing for the last 30 years? Yes, I know pretty well stuff that I need to do. But quite often when you get some specific type of job that you're going to have to perform, you're going to be educated on the equipment that is going to be handed to you. And the manufacturers and the distributors that sell those, they have people to go around to facilities and contractors and educating them on the new piece of equipment that they just released. They do that all the time. Okay? So the education starts at school here, but it never ends. And actually, some meters are so complex that and so expensive. Like a meter can cost like $30,000, $40,000, $50,000. So you don't buy those. Sometimes you just rent them for a day or two. But then you're going to have some basic understanding on how to do it. And some of those meters actually have live tech support, so you can properly use them. All right, meter leads. Do we have? Let's just go for 5 more minutes. All right, meter leads. All right, the red meter lead is connected to the voltage or resistance or the amperage port. It's considered to be a positive connection. So the ports are those little plugs that you use to plug those outlets that you plug in those plugs from the leads. What will happen if you reverse the leads? Well, nothing will happen, but you might get a wrong reading or you might damage something. Right? As long as, but if your red lead is broken, you have 2 black ones. As long as you know which one is which, sure, you can use it. But this is the basic convention here. You can get negative reading. However, yes, you can get negative reading. But look what happens here. If you have an analog, if you have a digital meter, you're going to be able to see it's just going to show you a little minus before at the readout. But look at this needle. Here's the analog meter. It's meant to go this way, right? From here to here. If you reverse those leads, it's going to try to go that way very strongly, and it won't be able to, so you can actually damage the measuring element here. So that's why. Okay, black meter connected to the common port, or it's considered to be negative. Probes. Here is a probe. You handle the probe like this. You can hold that. Probes are handles used to hold the tip on the tested connection. Probes are available in fused or unfused. Some of the more expensive probes, they're going to have a little fuse inside. So if you overdo something, you're not going to damage the rest of the equipment. And do we have any other? Oh, the wrong computer. All right, the tips. Tips are at the end of the probes. And provide the connection points to the items to be tested. Tips can either be a needle point or alligator clips. All right, display and settings. All right, so here's the digital display as opposed to analog display. So we're just taking care of the lingo here. Meter dial, right here. You use that meter dial. Turn this dial, why can't I just read this thing? Turn the dial to change the functions. Turn the dial to off position after use to save the battery. Sometimes meter use separate on and off power button. So you just have to know what the equipment is. So here's the dial. And here is, well, actually the dial, the meter dial. And, whoops, again, I'm pressing the wrong computer. Panel indicator right here. So you use the dial to turn the dial to point to whatever you want to measure. If you want to measure voltage, DC voltage, you will turn the dial to right here. Okay, and because this is a auto range, you are not going to have to worry about how big voltage you're measuring. Here. Probe connection ports. Meter, these are considered to be ports. So sometimes, okay, you would here, you would just plug in the black lead, and if you wanted to measure, because over here on top of the port it says V, omega, and a little kind of a temperature icon there. Diode and continuity. So if you're measuring those, you would put your red lead here. But notice, if you want to measure current up to whatever milliamps, we haven't, this meter doesn't specify it, and it's usually milliamps, you would use that. And this is usually up to 10. Actually, maybe it does specify, but I can't read it. You just have to know, usually 100 milliamps or something, or 20 milliamps, you can measure that. And then if you want to measure a bigger current, your red lead is going to go here, and your black lead also is going to go naturally to the black port. Do we have to use the multimeters outside of the classroom? Well, if you go to work and you need that, yes, you can use also. With some of the teachers might tell you, what's the room number? B1033. Okay, that's an open lab. B1033. It's at the end of the B building. There's a lab with some power supplies, with some oscilloscopes and some other things that you can actually do some of your labs there. If you don't have a power supply at home, you can go there. Just familiarize yourself with the rules and regulations and the COVID-related convention. Okay. Now, as far as the PowerPoint, we're going to stop here. We're going to continue this thing tomorrow. Thank you.